Welcome back to our second Teaching is Learning episode. Today's episode is Earth, Sun, and Moon. And to give you an idea what the pieces are for this, I've brought my notebook in and I can give you kind of a rundown of what we're going to do today. Uh, we're going to talk about the sun as it moves across the sky. And I'm going to give you a little talk about things and do my crazy stuff that you saw me do in the very first intro. And then we'll go outside by using an on-screen app that makes things look pretty neat that way. Then we'll talk about how the sun rotates, the moon rotates, and why the heck do things rotate? And then I will talk a little bit more about how I do my research for these episodes. And I'll show you a Google Doc where you can get the links to go to some of these really neat videos and resources that I use to come up with my ideas. Then I'll close out with some goofy thing at the very end. Maybe I'll make you laugh. Who knows how that's going to work out. Anyway, let me put my notebook down. Earth, or universe, or whatever you want to call it. In this little room, I can't see much. And I really don't know the passage of time in terms of the way the sun gives me the measure of days and the moon, the months, and those kinds of things. So in this room, I don't really have a good source of time. So another prop that I have here is an hourglass. Well, actually, this is only a 9-minute glass. The hourglass is way too expensive to have something like that in your house. Anyway, if I can bring this closer to the camera, you can see the sand is falling down there. And as that sand falls, we can come up with some kind of passage of time. And that'll give you some ideas that way. But hopefully, you don't just stay in a room. Hopefully, you get outside and you start looking at the sky and you see some stuff. And the typical thing, the prop that's used next, is a globe. And the globe is, let's bring it back here so you can see the whole globe. And it will, normally you think of it as a spinning globe and it's at an angle. And we'll talk about some of that stuff and try to figure out why that's the case. Now, let me bring that down. So, what is going on there? Where do we go from all this stuff? And in order to think about that, you have to know something about the fact that there's a sun up there. I see a light up there, so that's the sun. And you might, as you go out into the night sky and look at all the stars, it's really neat. And you might say, well, what occurred before all this? Oh, wow, creation stuff. Some people say Big Bang, or some people say gravity loops, or some people say it's a collapsing and expanding universe. Well, guess what? Those are just theories. It's pretty hard to test them because it's hard to go back in time and see what really happened. So, we'll get into creation later. We'll get into all these kinds of things. But all I want to focus on today is three things: Earth, Sun, and Moon, and see what we can learn about these things. Now, is it time to go outside yet? Well, are you ready to go outside yet? I could take my camera outside, but it's Thanksgiving Day and it's only 32 degrees. So there's no way I'm going to do that. Plus, this is a very low budget production and I don't have a camera person that'll take care of all this for me. So I'm going to stop the video now, or, well, I don't have to, but you can stop the video now and kind of think about what's going on, because I'm next going to go to a session here where I share the screen and we talk about some stuff that way. Before I go to that shared screen, let me say I appreciate all the feedback I've had so far. And guess what? It's all been positive. Either people are lying or you actually liked something that I did. Anyway, I guess I will close off this recording and I'll paste on the screen capture stuff that we're going to do. Thanks for listening, and don't stop yet. The video has more to offer. Hey, we're looking east. I'm using this really neat application called Stellarium, and it's at stellarium-web.org. It's free. That's why I like it. It's free, and we're looking east. The time is, you can see it's Thanksgiving Day. The time is 9 o'clock, and the sun's up there just about that far. So, let me hide this thing. That kind of gets in the way. So this looks pretty nice. We could wait here and run this video until the sun starts moving, but that's going to take quite a while. We're only moving at a few seconds at a time. So let's kind of check this view out if we speed things up. Okay, let's figure out how to do that. Let's see, can I speed things up? Okay, let's move faster. Oh, there goes the sun. There goes the sun across the sky. It's going across the sky. How come it isn't coming up directly in the east? Well, it looks like some of it's going to the south. Let me bring the sun up that way. Bring this thing down. Let's move a little bit farther this direction. Why is it in the south? Not quite sure about that. We'll have to figure that out. Why wouldn't it just come directly east to west? Let me advance my time here a little bit more. Whoop, the sun went down. Let's bring the sun up a little bit more. And this could get boring after a while because we're not moving very fast. So let's get things moving a lot faster. There's a way to do this if I can figure it out. Well, let's see. If I move the hours up, let's move the hours up and see what's going on. Whoop, going the wrong direction. So there we are. We're past noon. Whoop, let's move our view a little bit. There's the sun. What was that object there? That might be the moon. Maybe, not sure. Looks like the moon, kind of a half moon thing there. And let's keep going here. I'm going to move to the west. The sun's just about to set in the west. So let's see what happens as we're looking at that beautiful sunset coming down. And I will bump the time up a little bit more. Whoop, there goes the sun. There's the sunset. So now we've got the night sky. Why didn't the sun go directly from east to west? It's still kind of sitting in the south there. Hmm. Hmm. Maybe it's because of the tilt of the earth. See? That's something you should have thought about already. Should have figured that out. And because of the tilt to the earth, that sun's not always going to go east and west. Now, where is it going to go exactly east and west? Anybody out there? Anybody out there? That would be at the equator, wouldn't it? Wouldn't that be at the equator? Of course it would. Let's keep going and watch what else happens. Let's kind of go back here and see where that other object is. Do we have any other objects in the sky that we can look at? Oh, there's the moon. There's the moon out there, and it's in the south. And we can watch things change about that moon. If you want to get really fun here, let's bump things up really fast. Let's see if I can get things going really fast. There goes the moon. Oh, there's the sun again. Now, when I look at this picture, it looks like the earth is flat. Hmm. Well, maybe it is. Maybe the Earth is just this big flat surface, and we got these balls of fire. A ball of fire. The sun's a ball of fire. The moon's not a ball of fire, but this ball of fire, and it's going across the sky, and that's what keeps track of the days and all that kind of stuff. So then we're done, right? The story's done. Not quite. What happens if we use this? If I can do this correctly, we can show that the Earth is curved, and I can kind of zoom out here a little bit. Whoa, whoa, what's happening? What's happening? Let's see. There's the Earth. Whoa, it's curved. What in the heck is going on there? And if I bring it out a little bit more, there's the sun, and whoa, what's happening now? That looks like the Earth is curved. Of course, these trees aren't to scale. Those would be kind of small. But this gives a nice view of the fact that the Earth is a big ball here. Now, let's see if I can get this situated on here correctly. Now, let's go to full screen. That might make our life a little bit easier. Let's go to full screen. And let's see what this looks like. Let's bring it down a little bit to size, and let's bump that thing up and see what the moon looks like, or see what the sun looks like as we go across here. Let's bump this thing up. Let's get a little bit later. Oh, so now we say that the sun is orbiting this round Earth. That's kind of what it looks like, doesn't it? Kind of looks like the sun is orbiting the Earth. And we've got this thing is nice because it shows the planets. Shows the planets in the sky. And the sun it goes dark here because the sun is actually on the other side of the Earth. And then this thing goes around. So, okay, the Earth stands still and the sun rotates around it. Anybody see a problem with that? Well, that's what people thought for quite a while. First of all, they had to get over the fact that it wasn't flat. As you can see, during the time that Columbus went across his little voyage, he said, "Oh, it's not flat because I can see when a ship comes into port, I can see the top of the mast of that ship, and then slowly I see the rest of it. So the Earth must be curved, must be round, and so I'm going to get in my ship and go to India." And so he landed on the East Indies, which unfortunately turned out to be somewhere down near Florida, and he was wrong that it was India. And he called the natives there Indians, and he was wrong again. Those because he wasn't in India. Anyway, I digress. Not a little bit, but I digress a lot. So that should give you some ideas of how people got confused about stuff like this. I'm going to stop here. Might have to do some editing and chopping and see if I need to pursue this any further or if it's becoming way too boring. I choose the second one. It's becoming way too boring. No, some more talk from Mr. Larry the Learner. Uh, here's what I want to talk about next is rotation. Rotation. I'll quit looking at my monitor and look straight at the camera. That's what you're supposed to do, right? Talking about rotation. Why do things rotate? Well, when things come together, again, this is a theory stuff. You got a big bunch of dust or particles or matter or something happened that formed the sun. And before the sun was there, we had this swirling mass. So things were starting to rotate from the very beginning. And when it rotated, not when it rotated, when it came together, the particles kind of hit each other and it caused this rotational motion. That's a good theory. I kind of like it. It makes a good story. Now, the sun is starting to form and it's getting this big ball and fire and so on. And what's going around the sun? Well, before I even get to that, the sun rotates. I bet you didn't even think of that. I didn't even know that. I wasn't even thinking straight about that. But the sun rotates on its axis. It takes about 27 days for the sun to rotate. They figured that out by watching the sunspots on there. Anyway, let's just run back time a little bit. We've got all this swirling stuff going around the sun, and that kind of makes up the planets. Or at least when the particles jam together and they form the planets and so on, and the Earth forms and it starts rotating. And most of the other planets rotate in a normal way. There's a few of them that deviate from that, but that's just the way it is. So the Earth is rotating there. And the Earth rotates about once a day. And what about the moon? Okay, does the moon rotate? No, the moon doesn't rotate. That's actually not correct. That's something else I didn't think about. Something else I learned. Remember, it's Larry the Learner. What about the moon? The moon was formed by stuff rotating or forming around the Earth, so it should rotate too, right? It does rotate. The Earth rotates, now the moon rotates in such a way that it's always facing the Earth. As it goes around the Earth, it's rotating. If it weren't rotating, then we would see all the sides of the moon. And there'd be no such thing as saying that there's a dark side of the moon or the astronauts didn't go there, or it's all sorts of conspiracy theories about what's happening on that dark side. Well, those conspiracy theories can kind of go away because we have satellites out there that'll look at all points of the moon. So everything rotates. Let's see, how often would the moon rotate? Not sure where we're going to go with that. Not sure. But I wanted to emphasize in this little talk here about the fact that everything rotates. And without that rotation, we wouldn't have days. Without that rotation, we'd have to go for the sun to reach different parts of the earth. If it weren't rotating, it would take a year for the sun to traverse everything around the earth. And that would mean you'd boil. its sun would be shining on you, and the rest of the world would be freezing cold all the time, at least very slow. So that would be a pretty horrible thing. You couldn't live that way. So Earth not rotate, no life, everyone dead. Now it's time for one more segment where I'm going to show you how I research these topics. Oh, I guess I'm sharing. Anyway, the point of this segment is to show you how I keep track of stuff. Here's my little Google Doc titled Earth, Sun, Moon, which is, I think it matches the title of the YouTube video. And what I do is I put my main points, and then here's all the links to different articles that I use to research stuff. And you can see it goes all over the place. And let's see, I got to figure out a way to give you the link for this Google Doc. So what I'm going to try to do is put it in the comments of the section. In closing, I don't have anything really funny to talk about. Um, So, what I'm in closing, I would like to say that one of my viewers said that he'd like to find out what causes wind. So, in a future episode, I'm going to do that wind thing. If you have things that you'd like to learn about, just put that in the comments on this video, and I'll try to come up with one of these nutty things like that. Anyway, thanks for listening. It's time for Larry the Learner to sign off. Happy Thanksgiving.